Okay, everybody, our next unit is all about circles. So you should have received this handout. If you need to pause the video for a few moments so you can go ahead and assemble. If you want, you can definitely cut this strip off here. I'm leaving mine on right now just so that you can see all of the notes. But if you need to pause, go ahead and pause and finish assembling your book. Today our goal is to get through the vocabulary page and then the radius page. And then our following day we'll talk about the points of tangency. So again, if you need to pause, go ahead and do so. And the first thing we're going to do is we are going to talk about some vocabulary. And a lot of these terms you've probably already heard of before. They should look familiar to you. Sorry, I'm getting all situated here. Okay, so let's take a look at this first page. So at the top we have pictures of 3 different circles, and then we've got some terms down here at the bottom. And we're going to be kind of going back and forth with these throughout. So let's first just define what a circle is. And the formal definition of a circle is the set of all points in a plane that are equidistant from a given point. Again, it's the set of all points in a plane that are equidistant from, try something here, there we go, that are equidistant from a given point. I think I got a little shadow there. There we go. All right, so let's first talk about the center. I'm going to go ahead and label the center on my picture at the top. And the center is the point around which a circle is described. The point around which a circle is described. So up here in the definition of a circle, equidistant from a given point, that given point is the center. Okay, next we have what is called the radius. I'll go ahead up here at the top and label my radius. There's the radius. Oh, that's kind of hard to see. Let me try a different color here. Radius. Okay, so when we take a look at this radius, the radius is a line segment, has a definite start and a definite end, and it's going from the center of our circle to the edge of our circle. So that's how we come up with the definition for a radius. So it is a segment whose endpoints are the center and a point on the circle. I'm going to pause a moment. My daughter's going to come downstairs and sharpen her pencil. Okay, the next one is called a chord. Right there is my chord. So again, you'll notice that the chord is also a segment. There's a definite start and a definite stop. But you'll notice that both of those endpoints are on the circle. So a chord is a segment whose endpoints are on the circle. All right, next we have a diameter. All right, there's my diameter. Okay, so diameter, also a segment. It's definite start, definite stop. Both of its endpoints lie on the circle. So a diameter is a type of chord. But the difference between a diameter and just a chord is that the diameter is a chord that contains the center of the circle. Okay. Next, we're going to talk about what is called a secant. So we're going to go over to this circle upper right corner now. I'm going to label the secant. So the secant, it looks an awful lot like a chord, right? But it has arrows on either end. So a secant is not a segment, it's a line that passes through the circle at two different points. Okay? So a secant is a line that intersects a circle. Oops, can't spell. Intersects a circle in 2 points. Okay, next we have tangent, and this is not to be confused with the tangent that we just talked about with our right triangle trigonometry. This is a different type of tangent. I'm going to label my tangent on my picture. So again, upper left circle, upper right circle. Here's my tangent. So that tangent, it's also a line. But you'll notice that the tangent, it's only intersecting the circle at one location. Okay? So it's a line, and actually it can also be a line segment. It doesn't have to continue on in both directions. So it's a line or segment that intersects a circle at exactly 1 point. And then finally we have what are called concentric circles. And concentric circles look kind of like donuts. Concentric circles are circles that have a common center. So again, if you need to pause the video, go ahead and pause so you can get all of those definitions down. And I'll pull this down too a little bit. Again, make sure you have everything labeled correctly. And if you haven't done so yet for a radius, you're going to need a calculator. Okay, so now we're going to go ahead and flip up to radius. Okay, so radius says, not a radius, theorem says, in a plane, a line is tangent. So again, tangent means one point to a circle if the line is perpendicular, where perpendicular means 90 degrees, to a radius of the circle at its endpoint on the circle. Okay, so and the symbol for perpendicular is that upside down T. So it's kind of what happens. The radius of a circle and a line or line segment that is tangent to the circle, so intersects the circle at one point, they form a T, and we get that perpendicular angle there, that 90-degree angle. So here we can say that line M is tangent to circle Q if and only if segment QP is perpendicular to line M. Okay. Now, if I were to go from the center of my circle and extend to a point on that line of tangency, that tangent line, I now have a right triangle, and that's what we're going to be using next. So with our right triangle, the first thing we want to do is identify the hypotenuse, just like we did before. The other two sides, we're not really too worried about these other two angles right now, so we're not worried so much about our opposite and adjacent side. We are concerned with what side is the hypotenuse. The other two sides then are just called the legs. Whichever side is the hypotenuse, that's the side we want by itself. So the hypotenuse is squared. We can set that equal to our legs squared plus legs squared. And remember, that's called the Pythagorean theorem. So this is what we're going to use down here below. Okay, so let's take a look here at example 1a. I do think that this is a slight typo in a way. That 100 is supposed to extend all the way to segment AC. And it says, find the value of x. In all examples, segment AB is tangent to circle C. So if it's tangent, that means that at that point of tangency, we have our right angle. So we can go ahead and identify the types of sides we have in our triangle. So across from that right angle, that's called the hypotenuse, which means the other two sides are the legs. And we're going to follow this hypotenuse squared is equal to leg squared plus leg squared. So in this case, we have 100 squared is equal to leg squared plus leg squared. Well, one of our legs is x, and the other leg is 96. So 100 squared is equal to x squared plus 96 squared. So we're going to square both of these numbers. So we get 10,000 is equal to x squared plus 9,216. we're going to subtract our 92/16 from both sides. So now we have 784 is equal to x squared. So how do we get that x squared to just become an x? We're going to take the square root of both sides. And the square root of 784 is 28. So that is example A. I'd like for you to try example B on your own. Go ahead and pause the video, and after you've had a few minutes to work on that, go ahead and restart the video to check your work. So go ahead and pause. Okay, and for part B, you should find that x is equal to 64. All right, part C. Okay, again, that right angle, we can draw that in at that point of tangency. And then we can identify our hypotenuse. And then we can identify the two legs. So let's take a look at our hypotenuse here. It has two different values on it. It has a 16 and it has an x. And together, those two pieces make the entire hypotenuse here. So this hypotenuse is x plus 16. So we're going to do the quantity x plus 16 squared. And that is equal to our leg squared, so x squared, plus the other leg squared, 32 squared. All right, let's take a little side trip here. Let's talk about when a quantity is squared. So for example, if I said f squared, that really means f times f. So if I'm talking about x plus f squared, what I'm really talking about is x plus f times x plus f. Both of these sets of parentheses, those are called binomials because they have two terms. When we multiply two binomials together, we do something that is called FOIL. F stands for first, meaning we're going to take the first term in each binomial and multiply it. So x times x, and that is x squared. O stands for outer, so you're going to take the very outsides and multiply those two together. That's x times f. So xf. Or you can call it fx. I stands for the inside, or inner. So you're going to take the two inside pieces and multiply them together. And you get fx, or if you want to call it xf. And then L stands for last. So you're going to take the last term in each binomial and multiply that together. And you get f times f, which is f squared. So when we go back down here to look at our hypotenuse squared, this x plus 16 squared, what that really means is x plus 16 times x plus 16. So let's go ahead and FOIL. X times x is x squared. X times 16 is 16x. 16 times x is another 16x. And 16 times 16 is 256. If you notice, on the insides here we have some like terms. So this is x squared. We're going to combine those like terms to get 32x plus 256. Now what is this equal to? Go back up here. We had x squared, which is just x squared, plus 32 squared. And 32 squared is 1024. Run out of space here. Alright, so now, if you notice, both sides have an x squared. So they cancel each other out. Those x squareds are gone. So now we're left with 32x plus 256 is equal to 1024. Subtract 256. And 32x is equal to 768. Divide by 32. And x is equal to 24. Okay, so go ahead and one more time, pause that video, and I'd like for you to try part D on your own. So again, go ahead and pause, restart the video when you are ready. Alright, and you should get x is equal to 16 for this last one. Alright. So that is it for today. The substitute will have your homework assignment for you. Again, we're going to take a look at that last tab, points of tangency, tomorrow. So have a great rest of your day.